from Group B4 for our Unit Operation Lab 2 are going to present about our long report project, which is entitled The Application of Residence Time Distribution in Peptide Fungal Bioreactor Industry. So our group is consists of 4 members, which is Muhammad Fakharudin bin Shaharudin, me, Muhammad bin Mazlan, Muhammad Anwar bin Abdullah, and lastly Muhammad Azam bin Abdullah. I'm going to explain to you about the introduction and why we choose this industry. This industry is known that bioremediation, the process of bioremediation is used to treat pollution. So our plant is used to produce enzyme which can treat the pollution. And treating pollution gives a lot of profit because every company needs it. Every single company needs it to treat the pollution. So the last is our group project for our assignment based on RTD. So the objective of our plan is to obtain more insight about the growth of the fungi, and second, to construct the model of the production rates for the enzymes, and lastly to establish a tentative design basis for a commercial scale bioreactor. And now I'm going to present about customers' requirement. There are in real life we have many types of customers. So I'm going to describe about only 4 types of customers, which is loyal customer. Loyal customer, they are very satisfied with our product, so they will always buy from us. So in order to make them stay loyal as a loyal customer, we need to produce something that satisfy their needs. And second, discount customer. Discount customer is almost like loyal customer, but they need the product in lower price. So they will ask for lower price and lower, because when the price they want the lower price, the profit that we earn will be lower. So we must avoid this kind of customer. And the third one is impulse customer. Impulse customer is contrast, is totally different from loyal customer. This customer always search for something new, for like a company that produce the same but different price. They will go for the lower price. And the last one is need-based customer. This customer is good because the customer will make a research about what they are gonna buy, so they will come to us, and they will come to us only if they want it, only if they satisfy their needs. So in order to tackle this customer, we need to produce the product which is fulfill their needs. And lastly, why we need customers? Because customers is the ones who buy our products, and also we use customers' opinion as our guidelines for our last product. So I will pass the floor to Muhammad Anwar.
Assalamualaikum and hi, my name is Muhammad Anwar bin Halim 17536. So for now, I will be presenting about process description of the plant. Before we proceed with the plant, I will tell you a little bit more about tracer test. From the tracer test, we can know that it will trace something. So we will trace a thing which is a measured in a chemical compound. From this, we will inject this chemical compound into anywhere positioned in the upstream of the reactor, and we will observe the response in the downstream reactor. For this injection, it has got to be in 2 methods, which is pulse input and step input. So now let's proceed into the experimental details of this plant. First of all, we will inject a 5 ml of 0.1 sodium chloride into the space below the bag, which will then we observe the response based on its conductivity cells. Other than that, distilled water is also used at room temperature for this bioreactor, which then simulates the feed flow rate of the live bioreactor. Oxygen was also experiment to simulate the pulse oxygen to the live bioreactor. Now we will see the graph of this experiment. As you can see, for this upstream, it takes less time for the conductivity to reach optimum conductivity, rather than downstream, which takes more time for each to reach optimum conductivity. This is the process flow diagram of the plant, which is this one is the feed and this part is the oxygen. Feed combines with the oxygen plus with the injected tracer will produce an effluent, which is our product. So now I will pass the floor to Azam.
Hello, my name is Muhammad Azam. You can call me Azam. My part is about equipment, list, and unit description. So in this part, we have two things that I need to do, which is major equipment and minor equipment. So we go to the first thing, which is major equipment. So what is major equipment? In this system, we use packed bioreactor as our major equipment. But before that, we need to know what is packed reactor. So basically, packed reactor is used with immobilized or particulate biocatalyst. Number one. Number two, it's also supply continuous input and output. Number three, used for absorption operation to enhance gas liquid contact. Number four, and the last one, achieve bioenergy oriented packed material. The packed material supposedly to increase the surface of the contact of the gas and liquid phase. So we go to the, after we know what is packed reactor, then we go to packed bioreactor. The last one is reactor, now is a bioreactor. So what is packed bioreactor? Basically the function, the working principle is same as packed reactor. So the pack, previously I mentioned that the pack serves as the medium to increase the surface area, the contact of liquid and gas. So the pack in bioreactor also go same. The function is the same. So the gas phase can be introduced intermittently. Instead, it can produce by step input, pass input, co-current, and counter-current. But in this system, we were using co-current packed bioreactor, and the gas phase is dispersed by a pulsing mode. So this is about the unit that we study. So what is the function of the RTD in the bioreactor? So in the RTD, we need to determine the characteristic condition that occurs in the chemical reactor. Also, same goes to the bioreactor. And with the function also of RTD, we need to compare the behavior of the bioreactor and their ideal model. So what is the relation? As I mentioned before, the relation is in packed reactor, from the mixing characteristic that we got from the data, we will be able to scale it up to the industry reactor. So basically, according to our result analysis from our experiment, which is RTD packed reactor, we have A1, A2, B1, and B2, which is counter-current with step input, co-current with step input, counter-current with pulse input, co-current with pulse input. So basically, experiment A is about step input, experiment B is about pulse input. So in this experiment, we also use sodium chloride as a tracer to determine the RTD in the packed reactor. So this is some data that we got from the experiment. We got the mean residence time, various skewness for the experiment A, and for the experiment we got a stat input and also the plus input. So this from the time that we recorded according to the conductivity that we measured, we got this graph. So basically this graph tells us about the concentration at this time. So we can see that this is the stat input, and while the mountain like shape here is a pulse input. It also same goes to the when we calculate residence time versus time, and we plot it on a graph. So basically we can say that the shape of the graph of concentration versus time almost the same with the residence time against time. Basically that's the result that we got from the experiment. Alright, the first part I talked about the major equipment, which is back bioreactor. Now I want to talk about minor equipment that we use in our system. So basically, according to our PFD, we have two equipment that we use, which is pump and valve. In pump, we have nutrition pump and recycle pump. The function for nutrition pump is to flow the nutrition to the bioreactor, and the recycle pump, the function is to recycle back the unwanted enzyme, the other contaminant, back to the bioreactor. That's all for me. Thank you.
Hi everyone, hope you're doing fine. My name is Fakharudin bin Shaharudin 17556. So today I will be presenting about the safety considerations. So basically, if you can have a look here, manganese peroxidase. This is the enzyme that my previous teammates have actually mentioned, and this is also our product. So when it comes to safety consideration, I have actually put the material safety data sheet of the product itself here. But the thing is, this MSDS contains 6 pages and it is very tedious if I were to put it in PowerPoint. So basically, when it comes to safety consideration, you should always refer to material safety data sheet in any chemicals or material that you are dealing with. Right, so let's move on. Basically, I will be the one who will be doing economic analysis. So if you can see here, this is the reactor that we have chosen for our project in industries. Alright, so its name is Chemical Industry Packet Bed Reactor, and this is the estimation size of the reactor itself, and this is if you have put it in a room. Alright, so that's the reactor that we have chosen. So why do we choose this reactor? Have a look at here. So basically, it is a special equipment for chemical mixing and reacting, widely used in making resins, adhesive, cosmetics, and other chemical products. And also, it has distillation columns, condenser, water separator, collecting cans, filters, etc. So the thing is, when it comes to estimating cost of the plant, we are not actually calculating the whole cost of the plant. We are actually taking into account of one reactor only. Why? Because when it comes to calculating the whole cost of a plant, we don't actually have all of the data. So to make our calculation simplified, we are actually accounting to calculate only one reactor. Alright, so moving on. So basically, these are the applications of the reactor that I have previously mentioned. With this reactor, it is actually being used to process chewing gums, silicone liquid glue, washing powder, and many more. Alright? So basically, when you have a reactor, you're pumping nutrient with fluoride in it. What do you need else? What else do you need? Of course, a pump. So basically, this is the pump that we have chosen for this project. It is KIH, Chemical centrifugal water pump. So basically, this is the price and this is the look of the pump. The thing is, why do we choose this pump? This actually can be answered on this page. So, with this pump, its common application consists of chemical industries, fertilizer, paper mill, environmental protection, and seawater desal. So, the thing is, when it comes to choosing this pump, it is written chemical industries. What are we dealing again with the title of this unit operation law report? Industry of packet pen reactor with bioreactor. Right. So the estimated price of this pump is to be $210 up to $5,000. Alright. So let's move on. For the loss profit analysis, I also be doing this part. So basically, I actually tried to order the material, the final material, the enzyme itself from Sigma Aldrich. It is actually a company that is based in Malaysia, and fortunately they have this product, which is the manganese peroxidase. So if you can see here, this is my itinerary of ordering, but the thing is, this order has not been submitted because I decided not to buy, and this is just for my reference. So what can we see here? The price of for the powder of this enzyme is 770 ringgit. Along with tax, it can be total up to 816 ringgit. So when it comes, unfortunately, this company mentioned it in powder, and we don't actually know whether it is what is the weight. Is it 1 kilogram, 10 kilogram? So therefore, to further analysis of the loss and profit calculation, we have to assume. So basically, we have come to an assumption, which is 1 kilogram of manganese peroxidase is equals to 770 ringgit. Let's have a look at the production rate. And basically, this is how we calculate the rough income. Alright, so as I have mentioned previously, 1 kilogram of the enzyme is Rm 770 ringgit. So imagine if you can produce this enzyme for 10 kilogram a day. How much do you get? How much profit do you get? You will actually get 7,700 ringgit. Alright, so that is production of 10 kilogram within 1 day. What if you run this operation for 360 days, which is 1 year? How much you will get? An estimation of 2.7 million ringgit. Is it big? It is big. But this is the rough income. We don't know the clean income. Let's have a look at the clean income. Alright, so estimated clean profit calculation. So these are the particulars, and this is the amount. So basically, we have estimated that our profit to be almost 2.7 million ringgit Malaysia. But the thing is, you have to take into account of the pump and the reactor. For the reactor, the price of reactor, which is almost 35,000 ringgit Malaysia, and the price of pump, and we have two pumps, one pump for the nutrient and one pump is for the oxygen, is almost 17 grand times 2, because we have two pumps. And this is actually the estimation of raw materials, maintenance, overhead costs, and other expenditures, which you cannot expect what actually will happen. And we have estimated it to be 200,000 ringgit. All of these operations are best for operation for 1 year. So basically, this is your amount, this is your profit, and you have minus all of these things. What do you get? Your clean income. So we have actually estimated that from this project, you can actually get a clean income of 2.5 million ringgit. Is it high? It is high. So I guess that's all from me. I would like to pass the conclusion later.
Thank you, Mama Fakharudin. Now you have heard all of my group members' part. So I'm going to conclude all of our project. So the main objective of our experiment of our plant is to obtain more insight about the growth of the fungi, and also we need to develop the model for the production rates for the enzyme, and lastly establish a tentative design for basis for a commercial scale bioreactor. And the graph shown by Anwar shown that the residence time is increased and decreased back due to the concentration. And the time taken for conductivity efficiency in upstream is more faster compared to the downstream. And the system, which is Azam explained, the system consists of bioreactor which use the concept of RTD, pump and valve. And lastly, we can get high profit if the process and the price are known. Thank you.